Okay, so this section is about linked lists. After you understand about stack queue, so we are going to learn about linked lists and what is stack-based linked list and what is queue-based linked list. Linked list is one of the data structure that are commonly used in many real-world applications. And when we use a linked list, we have several elements. We call it node, and we will have head, and in the node we will have element, and every element it will have a link to the next node. So a single linked list is a concrete data structure consisting of a sequence of nodes. So I have, this is a node, this is another node, this is another node, this is another node, and then every node there is a link. Every node there is a link. Every node there is a link. So we call this is linked list. And if the link is only single, we call it singly linked list, because the link is only on one node, and then we connect or we have the link with next node. It is a collection of nodes that collectively form a linear sequence. Every node or its node, they have the element. Let's say this one, this is the element A. This is the element B. This is element C. This is element D. And then we have another thing to connect to the next node. So I know that A is connected to B. I know that after B is C. After C is D. After D is empty. Okay. And before A, we have one pointer, we call it head. So it is to indicate that A is the first. Some of the applications from the single linked list, we can have the routing sequence. So let's say I'm in Mohyeon and then I want to go to Mohyeon Sagori, and then after that I want to go to Songnam, and then I want to go to Gangnam. So yeah, we can make a kind of linked list. Delete undo operations. So if you know in any application, Microsoft Word, PowerPoint, Hangul, Notepad, you have the undo and then do. So those kind of things we can also apply with the single linked list. Photo viewer. So if you have a collection of pictures, you can go to the next picture. You can go to the next picture. You can go to the next picture. So this kind of things also use the singly linked list. And indirect application, we can use it for the auxiliary data structure. We can use a linked list for a list. We can use linked list in a stack. We can use linked list in the queues. We can use linked list in the arrays, and etc. And it can be a component of other data structure. So this is a kind of the structure. If we have the node, so we will have two kind of we call it data members. Okay. Maybe this structure is in the form of Java. Let me see. Oh, I think I will give you another example with Python. But let's see this one. The idea is the same. We have a class, and then we have two data members. The data members, the first data members is element, and the second data member is next. So we are going to check the next node. And then we have a constructor. We have a constructor. We want to get the element. We want to get the next. And we want to set the element. We want to set the next. So this is the very simple node class. Now, as you may know, in the data structure, we always have two kind of operations. What are they? The first operation is insertion, or we want to create, or we want to add a new element. The second operation is delete. We want to remove. Okay? We want to delete one of the element, or we want to delete node. Now, if we want to insert, when we want to insert, let's say that I want to insert at the head. What is head? Head is the first node. So I'm going to insert something in the head. So I will allocate a new node. So I will make a new node, insert the new element, and then have a new node point to the old head. So it means the head, which is now in the node where the element equals to room, now it will move to the next node, and then when we have this node, we will move the head into the new node. So we have the new node point to the old head, and then update head to point to the new node. So this is the new node, which is the Baltimore. When we have the new node, we just change the head pointer to the new node. So this is if we want to insert a new node and we change the head. What if we want to remove at the head? What if we want to delete? So in this case, update head to point to next node in the list. Let's say I want to delete the Baltimore. Then I know that Baltimore is now the head. First, I will move this head to the next node, and then after I remove this node, it will allow the garbage collector to reclaim the former first node. So in this case, you know, in the computer, whenever you delete some files, the files will go to a kind of garbage collector. So you can say in the computer, we have the trash bin. Digital. So we call this is the garbage collector. So whenever we remove this one, then yeah, it goes to the garbage collector. And when it goes to the garbage collector, then we will have the new sequence like this. Now, what if we want to insert at tail? If we want to insert at tail, so first we will make a new node. Let's say that we have the sequence of node is room, Seattle and Toronto, like this. And then we can insert a new element. So this is a new node. Let's say the new node is Zurich. So when we insert a new element, have a new node point to null. As I mentioned to you, the last node will connect to the null element or empty element. This is empty element. And then have all last node point to the new node. So we have the Toronto. At first, Toronto is connected to null. Then we will update this one. So the Toronto will have a connection to this node. And after we have the connection to Zurich from Toronto, we will update the tail. The previous one, tail is in the Toronto. Now tail has been updated to Zurich. So this is the step by step for the insertion and removal. How if we want to remove at the tail? So if we want to remove at the tail, it means we want to remove the last node. Removing at the tail of a single linked list is not efficient, because when we want to remove it, we need to start from the beginning to check for every single link, and then we will remove, and then we will update the tail to the previous node. There is no constant way to update the tail to point to the previous node. It means whenever we want to do the insertion and deletion, the best way to insert or the best way to delete, we want to have the constant time. It means I hope that we have O1. I hope that we have O1. But because every node is connected, and if we want to update or if we want to remove the tail, then we need to do n time. So because there is no constant time for the deletion and delete. So that's why we can combine the linked list with other data structure. For example, we can apply stack. So when we apply the stack as a linked list, we want to save the top element. The top element is stored at the first node of the list. So you know the stack. Okay. It means the top element is the first node. If we have the element, we have the element, we have the element. So the top will be the first, and the most bottom is the last one. We will use the space ON, and for its operation in this stack is O1. But as you know, if we apply this stack, and if we remove the tail, it means it takes ON. This is the code in Python. The previous one I show you the code in Java. We can look at the code in Python. In this case, I have the class link stack, and inside of this class I have another class we call it the node class. And in this node class, I think you already know this is the constructor. In this constructor, we want to create two kind of data members. The first is element and the other is next. So the next, it is about the reference to the next node, and the element, it means we want to know what is the element of this node. So this is the node class. And after we have this node class, let's move on to the stack. I think you still remember in the stack, we can know the length, we can see whether the stack is empty or not, and then we have push. Do you still remember push? So push means we want to put the element into the stack. Pop, it means I want to know if I have the stack, I want to know what is the element using this function. Pop, it means I want to know what is the element that I want to remove. Okay. So we have push and we have pop. And for every of this function, we can make another kind of statement. For example, if I push, so if I push into the stack, it means I will update the head. So the head now it becomes the new node, and the size will be identified. If I pop, it means I will check whether it is empty or not. If it is empty, then it will give you some error message. If it is not empty, then let's check the head element. And then let's move the head to the next element, and the size will be -1. So in the link stack, we will start with the size equals to 0 and the head is null. Yeah, that's the linked list with stack. Or we can use queue for this linked list. In this case, we have the front element and we have the rear element. So you know already when we have the question in the exam, we learn about the front and the rear element. So if it is the head, it will be the front. If it is the tail, it will be the rear. And we can have the space is on because it is depending on the number of elements. And then if we want to do the operation insertion and deletion, it will take O1, like you learn on the queue. So this is the linked list queue in Python. You can define the class linked queue, and then again you will have the node. So here it is omitted. It is identical with the link stack node. It means it is the same with the one that you learn here. So the node will have these two data member. And then, as you may know that in the linked list, we need to define the head, we need to define the tail. And then in the queue, we have the length. It means how many size do we have in the queue. is empty. We want to know whether the queue is empty or not. And then we want to know what is the first. The first means the head. So we can define the first as the head, and then we can return the element of the head. If you still remember the queue, we have DQ operation and NQ operation. DQ operation means when we have a queue, so if we do the DQ, we will remove. If we have the NQ, we will input another element. So in the DQ, if it is empty, then we can just give Q is empty. If it is not empty, then the answer will be the head of the element. So the head will be removed. And then let's move the head to the next element, and the size will be minus by 1. If the element is empty after we remove the element, then let's change the tail equals to none. If we do the NQ, we will create a new node first. After we create the new node, then we will check whether it is empty or not. If it is not empty, then we will just make the tail equals to the newest, or if it is empty, we will just put the newest as the head. Afterward, we will assign the tail as the newest, and then the size will be added by 1. So that's the singly linked list. Now let me move to the second slide. It is about the doubly linked list. The doubly linked list, we call this the doubly linked list ADT. Do you still remember what is ADT? It is abstract data types. Okay. If we look at the doubly linked list, it is similar concept with training. So the doubly linked list provides a natural implementation of the node list ADT. So the node list is the same with the node that I just explained on the singly linked list. But now, when we apply the nodes here, there is one more thing which is about the position. So the node will have the position, and then the node will have more element which is connected to the previous. So if it is singly linked list, we have only the element and how this element connect to the other element. But if it is doubly linked list, it means we want to know that this node have a connection to the next element, and this node have a connection to the previous element. So nodes implement position and store what is the element, and then what is the link to the previous node, and what is the link to the next node. Now in this case, we have a kind of special nodes. We call it, this is special nodes. Header, it is to indicate that this node is the head. And we have a special node, trailer, to indicate that this node this node is DN. So the doubly linked list, maybe you have the music player. We have the next and previous buttons. So we can use the doubly linked list for that one. And you know the browser, in the web browser, you have back, forward, and you can go back. It means you can go back to the previous page, or you can go forward. You can go to the next page that you already searched on the browser. Undo, redo. Okay. So this is also the application for the doubly linked list. As you might know, we always have two kinds of operations. Whenever we have one data structure or abstract data type, we will have the insertion, and then we have deletion. Now, how if we want to insert a node? If we want to insert a new node, let's say I want to insert Q, and then I want to insert Q, it is in between P and its successor. I have, this is the first node. Let's say this is the header, okay, and this is the trailer. So this is the first node, this is the second node, and then this is the third node. I have, this is the P, or the node P, and I want to insert a new node Q between P and its successor. So it means I would like to insert the Q. The Q is in between P and this successor. Yeah, the idea is to make the new node. After we have this new node, then we will update the connection. If you can see this one, A is the element, and this is the previous connection. This is the next connection. This is the next connection. This is the previous connection. So if we want to make a new node in between this one, then we need to update this one. We need to update this one. We need to remove this link, and the link will be updated to the new node. So the new node will have the connection, the next node to the C and the previous node to this P. And then this P will have connection to this Q, and the last node, the C, will have connection to this Q. If we want to delete, let's say I want to remove P from a doubly linked list. So I want to remove P, this one. Then I can remove this element, and the next element or the next item from the C, it can be connected to the spatial node, which is the trailer, and then this spatial node, which is the trailer, can be connected to the last element, and then we can just remove this one. This is the doubly linked list. There's a class doubly linked base, and then the node. So in the node, yeah, you can make the node with the element, and then you can have the next, and you can have the previous. So those three are the data members. And then This class have the constructor. You know the constructor. We have the init, and we have the header. The header is a node, so it is a special node. Why we have none, and none? There are three elements. None, none, none. What does it mean? So we have three kind of data members. The first data members is element. The second data member is the next. And the third data member is the previous. That's why we have three parameters. And because this is a special element or special node, so we just put everything as node. And we also create another node, which is non for the trailer. For the header.next, we will connect to the trailer, and for the trailer.previous, we connect to header. It means if we have this header, if we have this is the trailer, so we connect to the trailer and we connect to the header. So in the first time, there is no element in between. And then we want to know the length. It means the size. I want to check whether it is empty or not. So in this doubly linked list, what I explained before, you have the insert between and you have the delete node. So the insert between, I want to make the newest, so it means I will create a new node and then I will have the E, which is the element, predecessors, and successors. So this refers to the previous, this refers to the next. So the predecessors dot next equals to the newest, and the successors dot previous equals to the newest. And then the size will be added by 1 and return the newest. When we want to delete the node, so I'm just giving a parameter which is the node, and for the node I would like to check what is the predecessor, which is the node dot previous. I want to know the successor, which is the node dot next, and then for the predecessor dot next I will change it to the successor. For the successor dot previous I will change it to the predecessor, and then the size will be minus by 1. And now the elements will be the node dot element, and then the node dot previous will be the node dot next will be the node dot element. Now it becomes none, or we want to remove it from the doubly linked list. And the last one, we just written the element. So it means the element has been deleted. When we want to use this doubly linked list, the space used by a list with n elements, most the data structure with linked list, stack, and queue, they have the space on, because they have the n element. The space used by each position of the list is O1. So if we have one position and we have another position, so it is O1. And all the standard operation of list run in O1. It means if we insert, it is O1. And if we delete, it is also 1. There's another type of the list, we call it positional list. In this positional list, it is to provide a general abstraction of a sequence of elements with the ability to identify the location of an element. Okay. This is the keyword, location of an element. The meaning by location means, we want to see the position of that list. A position acts as a marker or token within the broader positional list. A position P is unaffected by changes elsewhere in a list. The only way in which a position becomes invalid is if an explicit command is issued to delete it. So the position, it will keep in that element as long as you never delete it. So a position instance is a simple object supporting only the following method. So if we have P dot element, it means return the element start at the position P. So we will define the position with a kind of notation. So in the positional operations, we have several more operations like this one. L, let's say this is the list. List dot first. Okay, then I want to know the position of the first element of L. L dot last, it means I want to know the position of the last element of L. L before P. So I want to know the position of L immediately before position P. Or known if P is the first position. So let's say if I have a sequence of elements, if this one is P, then I want to know what is before P. So it means this one. But if the P is here, then it means there is no element before P. Then we can return none. Sorry, no. After P, this is also the same. If we have P here, then we can know that this is the after P. However, if the P is the last element, then after P is none. And then I can check is empty or not. I can check the length or the size of the list. And then iter. Do you still remember iter? When we use iter means it is a kind of iteration. So if we have 1, 2, 3, 4, 5, 6, we will do the iter. It will start from the first element. If we call iter, we call the next element. If we call again iter, it will go to the next element. So the element will be called one by one according to the sequence. So in the positional update operations, we can do the add first. So it means I will add the element in the first position. I can add the element in the last position. We can have add before and we can have add after. Add before means I want to add the element before P. Add after, it means I want to add the element E. after P. And then I can replace the element E, and then I will return the element formerly at position P. And then I can delete the P. So this is an example. Let's say this is the L, this is the list. The table shows a series of operations of initially empty positional list L. So the first one, it is empty. To identify position, variables such as P and Q are applied. So the position means, we use the P and then Q and then R and then S and so on. Okay. For each exposition, the list contents are displayed with subscript notation to denote its position. So for example, like this. I have the L and then I want to add the last. What is at last? At last means insert a new element at the back of L. So at the end of the L. Then I will just have the new list, which is 8, because I add the element 8. And then the position is P. So the return value will be the P. L dot first. Oh, I want to know what is the first element. Because I only have one element, then it is 8 P. Because I have only one, then it will return P. Add after P, comma 5. It means I will add the element 5 and it is after the P. And as we mentioned here, the variables, we are going to use P and Q. I'm going to add, I want to check before Q. What is before Q? It is P. I want to add before Q, comma 3. So I know this is the Q, I know this is the P. So before Q, I will add 3. And as I mentioned to you, we have the P and then Q and then R and then S and so on to indicate the position. So the position now is R. I want to know what is the element of R. Then it is 3. What is after P? We know that after P is R. What is before P? Before P is nothing. Then it returns no. I want to add the first with 9. So the first element is 8, but because I want to add one more element 9, I'm going to use S to indicate the position. So now it becomes 9S and it returns S. I want to delete the last element, and the last element will be this one. So it will return 5 and then this element will be deleted. So now it becomes 9S, 8P and 3R. I want to replace the position P with element 7. So the element P, now it is 8, but I want to replace it with 7. Now it becomes 7. But when the return value, it mentioned the previous element. Okay. So this is the code for the position list. the position list, it is inherited from the doubly linked list. So if you know already the doubly linked list, yeah, it is inherited. That's why you learn about the object-oriented inheritance, because in this data structure, there are many data structure which is inherited from other data structure. So we have the class position, we have a constructor, and then we have the element. We can check the equality, we can check whether it is not equal, and we can check the validation. So what you already learned from the previous chapter, from the previous pages, we learned about the first, what is the first element, what is the last element, what if we add before. We want to check what is before P, what is after P, and then this is the iteration. It means we will go for every of the element. Insert between the predecessor and successor. We want to add the first, we want to add the last, we want to add before, we want to add after, we want to delete, and we want to replace. So those are the code. I think if you understand how we can do with Python, you can easily understand the code. So the linked list, there are two types that you already learned. The first is the single linked list, which is a connection with one. So it means this node will have connection to the next node. This node have connection with the next node. If we use the doubly linked list, it means the node will have a double connection. So this node connect to the next, this node connect to the previous. Actually, there is another kind of linked list, but I think I will skip this one. It is the circular linked list. So the idea is similar to the queue that you already learned, the circular queue, and we can also use it as a linked list. Okay, I think that's all that we can learn. Let's have a break. We will continue after the break.